Yeah, hi, I'm John Dawson with ExactData, and I'm here to talk about a topic you're probably not aware of, and that's high fidelity fully synthetic data generation technologies. Today, test and training data, training both for humans and AI ML systems relies on modifying production data sources. You're either manually accessing the data and modifying and creating the use cases, or using ETL technologies, extract, transform, load, Informatica, IBM Optum, Mathematica to help with that process. But still, it relies on modifying production data sources, and it's still fundamentally a manual process, even with the automation. And that's problematic. On the one hand, you have growing privacy and security issues. You've got cyber risk is growing, cyber threats, and then you've got policy restrictions on what can be done with data. It's becoming much more restrictive about what can be done with this data, such as the GDPR. And on the other hand, you have a growing need for data. Your technical ecosystem can't do their job without access to relevant databases. And it's not just internal software development, it's your ecosystem, it's your technology partners, it's your integrators, it's your internal software development, it's your offshore partners. They all need access to this data. And what we've done is we've come up with a way to break that chain. So we can generate the relevant databases that are designed for the system under test. They mirror these production data sources, and yet they're fully synthetic. So they have no ties or connections to these production databases. So that chain's been broken. The way we do that is we basically have a sophisticated rules engine. We get requirements, what these databases need to look like, what the business rules and workflow logic needs to look like, statistical distributions, what the use cases and software development requirements that need to be engineered in the data need to be. We create what we call data models of these systems of systems. We generate a model universe, so we're generating all these databases that make sense or are correlated, and then we're outputting whatever the client needs, for that particular test or training or sales and marketing purpose. And we're outputting however the client wants to consume it. SQL insert scripts, XML files, flat files, whatever they need to populate those systems. It's got some key advantages. We talked about the privacy and security issues. You can release it as part of an RFQ or a quoting process, RFP. You can ship it offshore. It just doesn't have any privacy or security restrictions. You can help your technical ecosystem do a better job and feel comfortable doing that. And it's a classic cheaper, better, faster too. It's cheaper because once you create these data models, there's no cost of regen the data. So it's invest a little, and usually the investment's less than generating the data with one ETL cycle. And then you can continually regen the data that you need. So it tends to be much less expensive and much less labor involved in getting the data that you need. It's much better. The ground truth. You actually have very high use case coverage, 95% versus 10 or 15 with traditional processes. You're generating not only data, but the system response files, and you're generating for the use cases true and false positives and true and false negatives at statistical volume. So you can create a confusing matrix and actually score the system for precision or error rates. And not only are you measuring error, you know exactly where the system fails. You can go back in and make corrections to your software and make it better and reduce that cost of error. And it's much faster. You have relevant data when you need it for your development teams, and it has a big impact on accelerating your software development processes in your time to market for products. It's proven technology. It's been a critical technology component, some of the biggest IT projects in the world. As just one example, for the recent United States Census 2020, it's $4 billion in IT spend. We generated data for the 60 systems of systems, so correlated across all these systems, future state system, and that's how they developed and tested and deployed this very large IT system. And then we're providing the data to all these development teams, how they wanted it, such for a fraud system, but the data was all being generated and correlated across this model universe. We talked about some of the cost savings. The cost of gen the data is less. You're reducing your cost of error. You're reducing your development cycle times. But there's a big cost associated with reducing cyber risk. $6 trillion are estimated for cybercrime in 2021. There's $6 billion in gross insurance written premium. So there's a huge disconnect there. There's trillions of dollars in gaps there between what's covered from an insurance perspective and what these actual costs are. And the majority of breaches are through third parties and through your DevOps environments. It's estimated 60%. So there's trillions of dollars in opportunity cost to actually be by deploying this technology by reducing your cyber risk. Thank you very much.